Okay, so empirical formulas are the easiest. So the empirical formula, and I'm going to abbreviate it EF, is going to be the simplest ratio of ions in an ionic compound. So, for example, for an ionic material, the EF is going to be something like Al2SO4 3. So, that is the simplest ratio. Now, there's also something out there called the molecular formula. All right, and the molecular formula, we saw this in benzene. It was like C6H6. So that's the molecular formula, and that's the ratio of atoms. But the key word here, in a molecule. All right, so ionic stuff's different than molecular stuff. So the EF for C6H6, I hope everybody can see that you could divide everything by 6. So the EF is going to be just simply CH. So that's the EF, or empirical formula, and the molecular formula is there. Now, these two are related by a whole number ratio. So here, the EF and the MF are related by a whole number ratio of 6. And by the way, I just want to add that if they're related by a whole number of 6, since it has all the same elements in it, then the mass of the MF over the mass of the EF is also related by that same whole number ratio. All right, so we're going to use that information to solve some problems. Now, to solve the empirical formula, let me erase some of this stuff off of here. So, to solve for an empirical formula, you're usually given percent composition. So, when you see one of these problems, to find the EF, you start with an empirical formula. All right, so let me just go back to black here. So to find the EF, you start with a percent composition a lot of times, and then you use a little rhyme I had taught you in class. All right, so from the percent composition, you basically just start with this little rhyme, and you say percent to mass, mass to mole, and divide by small. And then finally, you multiply till whole if you don't get whole numbers to begin with. If you get whole numbers, that's the empirical formula. Remember, empirical formula is the ratio, simplest ratio of atoms in a compound. So, again, how do you do this? What trick are you pulling? Really, if you get a percent composition, you are pretty much saying, look, if I get a percent composition and I assume I've got a 100-gram sample, I can just take the percent, assume 100-gram sample, and then I can just take all my percents and change them over to grams. All right, so that's pretty much the trick I'm going to pull as I'm calculating this stuff. I want to remind you that you can pause this at any time and go back and kind of look at what I just said and see if you can make those relationships yourself. So anyway, here is our problem that we're going to try to work for an example. Adipic acid is an organic compound used in the making of the synthetic polymer nylon, and it's also known as nylon 66. It's composed of 49.31% carbon, 43.79% oxygen, and the rest hydrogen. Find the empirical and molecular formulas if the molar mass of the molecule is 146 grams per mole. We're going to start by finding the empirical formula. So we're going to find the EF. And what do? We take our little rhyme, percent to mass, okay, mass to mole, divide by small, ALL, and then multiply till whole. All right, there's our little rhyme. You can go back to the other page, or you can go to your homework or class copies and have a look. So, first thing we're going to do, we're going to say for carbon, we have 49.31 percent carbon. But I'm going to use that trick of saying, look, we have a 100-gram sample. So I'm just going to change it to grams. I'm going to put hydrogen next because a lot of times when we do these carbon, hydrogen, oxygen compounds, hydrogen comes next in the formula. I'm going to stick with that convention. I'm going to look at oxygen now and say, oxygen's 43.79%. So 43.79, but instead of percent, I'm going to assume the 100-gram sample, I'm going to call it grams. All right, and then to find our hydrogen, we have to sum. Let's see. So 49.31 plus 43.79, and we're going to take 100 minus that. And percents, when it comes to percent composition, they pretty much always add up to 100. So when I do that, I'm going to get 6.9% hydrogen. Okay, so I'm going to carry that number over to the left, and I'm going to say 6.9 grams of hydrogen. Okay, so I'm going to erase that off. Then what we're going to do is we're going to take that, we're going to run it through our little rhyme and figure out our empirical formula. All right, so I think I'm going to stay with blue here. All right, so carbon weighs, now we go percent to mass. All right, I already did that. Okay, I've got masses all the way down the line there in grams. Percent to mass, and then now percent to mass. Now we go mass to mole. Well, that's saying do a mole conversion. One mole of carbon is 12 grams. 1 mole of hydrogen is 1 gram, and 1 mole of oxygen is 16 grams. All right, now you notice here I did not use diatomics for hydrogen and oxygen, and the reason I didn't is because you're doing an empirical formula. This is the ratio, simplest ratio, the atoms to each other. Atoms, all right? So I know we've talked diatomic this and diatomic that. This is one of the few places where you don't use them as diatomic because you're looking for the simplest ratio of atoms. Okay, so now we plug this stuff in our calculator. I'm going to do the easiest one before I pick up the calculator. 6.9 mole there. Let's see, 49.31 divided by 12 is like 4.11. And remember, that's all mole. And then 43.79 divided by 16 is 2.74. 74. And again, folks, this is all mole, mole, mole. And then this thing, our next thing in our rhyme, it says divide by small. So you take the smallest number, that's going to be 2.74. 74. 2.74, 2.74, and out pop some numbers, okay? So those numbers are 1.5, okay, so this is 1.5 in my calculator. Oh dear God, what did I do? Sorry, 43 okay, 2.74, yeah, I got that right. So that's going to be 1.5 there, 2.5 by hydrogen, and then 1 for the oxygen. Okay, so 2.74. Okay, yeah, I got it right now. So I've got 1 to 2.5 to 1.5. Now if I go back to my rhyme, I divided by small, but you notice that these guys are not whole numbers. So I have to multiply till whole. And if you notice everything, you have to multiply everything. And you start, okay, I multiply by 2 and then by 3, and to try to get whole numbers. So I'm gonna take this thing and I'm gonna multiply it by 2, and I'm gonna get 3 to 5 to 2. So my empirical formula, now that I've got whole numbers, is gonna be C3H5O2. C3H5O2. So that is the empirical formula for this stuff called adipic acid. Now I'm going to take that number over, okay? So my EF is equal to C3H5O2. I just transferred it over here. Found it on the last page. You guys can pause, you can back up, you can do whatever you need. And now there's my empirical formula, but now it tells me that the mass of the molecule, is 146 gram per mole. All right, and then here, I need to find the mass of the EF, because if I take the mass of the small guy, the empirical formula, and I take the mass of the molecule and divide it by the mass of the small guy, that's going to give me that whole number ratio. So let's see. So the mass of the EF, all right, I've got 3 carbons, so it's going to be 36 plus 5 plus 32. And just to make sure everybody's on page, I have 3 carbons, so 3 times 12 is 36. I've got 5 hydrogens, all right, so 5 times 1 is going to give me the 5, and then 2 oxygens, 2 times 16 gives me 32. So the mass of this whole thing now, if I just take it and sum it up, all right, I'm going to go back and look at this. It's, let's see, I've got 8 and 5 is 13, 1, did I do that right? Let's see, 7 and 6, yeah, it's 13, and then 73 grams per mole. So the mass of this guy is 73 gram per mole. I take and I plug it down here, 73 gram per mole. My unit gram per mole kind of cancels out, so 146 by 73 equals 2. So that's my whole number ratio of the difference between the empirical and the molecular formula. So now I take my empirical formula, which is C3H5O2, and I multiply it through by this whole number ratio, okay? And then so what I end up with is C6H10O4. And so that is the molecular formula for adipic acid. How do I check myself? I go back and I say 6 times 12 is 72, 10 times 1 for hydrogen is 10, and 4 times 16 is 64. You sum those up and it should sum to the 146 gram per mole. And that's more of a check step. But anyway, that's how you do empirical and molecular formulas.